So this is the pole, and here we have F1 and F2 focus, and here O and O dash is the object. Yes, this is the O and O dash is the object, and I and I dash is the image here. So here HO, here HO is the height of the object and HI is the height of the image. Yes, when we draw the ray diagrams from this point of object O dash, so we got the image here on the other side of this convex lens. We are using only convex lens here. So already we discussed this about in the lens formula. We know the object distance, how to measure the object distance from pole to the object. Here this is the object distance, and here this is the image distance, pole to the image, that is V. So here observe object O dash and image I dash. So from this diagram, the triangle O dash P, here O dash and P. Yes, and triangle I dash P. So these are the similar triangles. Yes, triangle O dash P and I dash P are the similar triangles. So from this we can write here I dash by here I dash by PI, which equals to O dash by PO. Okay, so here I dash by PI equals to O dash by PO. So from this I dash by O dash equals to PI by PO. So here substituting the values as per sign. Okay, sign convention here. Substituting the values as per sign convention in this above equation. So we know I dash is the image, right? So I dash is the image height, that is a HI, and O dash is the height of the object, and PI is the image distance. P to I is the image distance, and P to O is the object distance. So we can write here I dash by O dash equals to PI by PO. So from this we can write minus HI by HO equals to minus V by U as per sign convention here. So therefore, so magnification equals to, so magnification M equals to HI by HO, or which equals to V by U. So HI is the image height and HO is the object height here. Right now, is the focal length same for each set of values? So here we might have noticed that irrespective of object distance and image distance, you will get same focal length. Okay, here for the object distance and image distance, the focal length is same. So if you do not get the same value of focal length, so there may be some experimental error while doing the experiment. So in such a case, find the average of all the values. So this will be equal to the focal length of the lens. But actually, so the focal length is same for each set of values. So here, let us see an example that is an electric lamp and a screen are placed on a table. Okay, so this is an electric lamp and here we have a screen. So placed on a table. So in a line at a distance of 1 meter. So in what positions of convex lens of focal length of f equals to 21 centimeters will the image of lamp be sharp? So what they are asking, in what positions of convex lens of focal length f equals to 21 centimeters will the image of lamp be sharp? So here the distance between the lamp and screen, okay, the distance between the lamp and screen is 100 centimeters. And x be the distance between lamp and lens. Okay, here this is a convex lens. So here x is the distance between lamp to the lens. Okay, the distance between lamp to screen is 100 centimeters. Right? So we have u equals to minus x and v equals to 100 minus x and f equals to 21. So why we are taking here minus x means here we are applying the sign conventions, right? So v equals to 100 minus x, right? So that means here the distance between the lamp to the screen is 100 and the distance between the lens to the lamp is x. So to find this screen, that is image distance, that is 100 minus x, and here f value we given focal length, that is 21 centimeters, right? So by substituting these values in the lens formula, yes, so we'll get here 1 by x. Already we know the formula, 1 by f equals to 1 by v minus 1 by u. This is the lens formula, right? Substitute all the values in this equation. So f equals to, we know 1 by 21. So equals to 1 by v value is 100 minus x. So here we have minus. So u value is a minus x. So it becomes now 1 by 21 equals to 1 by 100 minus x plus 1 by x. So after solving this equation, we get here x square minus 100x plus 2100 equals to 0. So solve this equation, we'll get this value here. X square minus 100x plus 2100 equals to 0. So now it is a quadratic equation, right? So hence we get two solutions. So what are the two solutions here? So the solutions of this above equation are x square minus 70x minus 30x plus 2100 equals to 0. Right? So here, from this we can write here x into x minus 70 minus 30 of x minus 70 equals to 0. So what we'll get here, x minus 70 into x minus 30 equals to 0. So we got here two values, x equals to 70 centimeters and x equals to 30 centimeters. So we can place the lens at a distance of 70 centimeters or 30 centimeters from the bulb, we get sharp image. Okay. So at what distance we have to place the lens means at 70 centimeters or 30 centimeters. In both these situations, we'll get sharp image on the screen. Yes. On what factors does the focal length of the lens depend? So let us find out that. So by doing an activity, we are finding that here. So now, take the same lens that was used in lab activity, right? So the same lens we are using here. Yes, convex lens only we are using. So note the average focal length of the lens. So that was calculated in the activity. See. So take a cylindrical vessel such as a glass tumbler. Its height must be much greater than the focal length of the lens. Okay, so here we have to take one cylindrical vessel such as a glass tumbler. Now its height must be much greater than the focal length of the lens. So here we require the vessel which has a length nearly equals to 4 times of the focal length. So we require the vessel which has the length nearly equals to 4 times of the focal length of the lens. So now keep a black stone inside the vessel at its bottom. Now pour water into the vessel up to a height such that the height of the water level from the top of the stone is greater than the focal length of the lens. So you can observe here, this is the length here and this is the water level. Yes, we pour the water into the vessel up to a height such that height of the water level from the top of the stone is greater than the focal length of the lens. Now tip the lens horizontally using a circular lens holder. This is the circular lens holder here. Now, lens is above the stone here, right? Now stone is at the bottom and here the lens is above the bottom of the stone here. So set the distance between stone and lens that is equals to or less than the focal length of lens, which is measured in activity already. So now look at the stone through the lens. Okay, look at the stone through the lens. So can you see the image of the stone? If yes or not, why? So give your reasons they are asking. So here you can see the image of the stone if the distance between lens and stone is less than the focal length of the lens. Okay, so here we can see the image of the stone when the focal length of the lens is less. So here now increase the distance between the lens and stone. So continuously we have to increase the distance between the stone and lens here. So here up to when? So here until you cannot see the image of the stone. So what do you conclude from this activity? Does the focal length of the lens depends on surrounding medium? So here when the distance is increased from the stone to the lens, we cannot see the stone from the lens. Okay, and here we can say that the focal length of the lens depends upon surrounding medium. Yes, so focal length of the lens depends on surrounding medium. So when the lens is inside the water, yes, so we observe the stone through the lens. When the distance is increased, stone to the lens, we cannot see the image of the stone. So here to observe this, focal length depends on the surrounding medium. So here you have to put the lens to a certain height which is greater than the focal length of lens in air. So here you can see the image, right? When lens is raised further, you could not see the image. So this shows that focal length of lens has increased in water. So we conclude that focal length of lens depends upon the surrounding medium in which it is kept. So next we have lens maker's formula. So very important one this. So here, imagine a point object O placed on the principal axis of the thin lens. Okay, imagine a point object O placed on the principal axis of the thin lens. So now, this lens be placed in a medium of refractive index Na and refractive index of lens medium be Nb. So I'll show the figure here. Consider a ray from O which is incident on the convex surface of the lens with radius of curvature R1 at A. So I'll show you here. Right. So here this is the principal axis. Right. So here we have the pole. Here R1 and R2 are the radius of curvature. So here this is a point object O on the medium, refractive index medium Na. Now this is the object O here. So this is the incident ray from the point object O touches the lens here at point A. Yes. So here the incident ray refracts at A, right? So from this point, this ray is refracts. So here, like this. So let us assume that it forms a image at Q. So if there were no concave surface, the image will be formed at point Q here. So that's why here we are taking the dotted lines here. Yes. So here, from this we can write the object distance. We know already the every distance on the principal axis we measured from the point P. That means pole. So the object distance PO is the object distance, that is minus U, because the incident ray is in this direction and the distance measured of the object is in opposite direction to the incident ray. So that's why we are taking here PO equals to minus U. And image distance, that is PQ. B equals to PQ now here. P2Q. So that is X here. Here, radius of curvature, that is R equals to R1 here. Yes, we are taking only refractive index of first medium. Now, here N1 equals to Na and N2 equals to Nb. N1 equals to Na and N2 equals to Nb. N1 is the refractive index of first medium and N2 is the refractive index of second medium. Now, substitute the above values in the equation. Right? So here N2 by V minus N1 by U equals to N2 minus N1 by R. So substitute all the values in this. So NB is the second refractive index here. So that is N2 equals to here NB. Here we know V equals to X and N1 is the Na and U equals to U already. Yes, we are taking plus U here because already here we have, that is U equals to minus U, that is PO equals to minus U. So that's why we are taking here plus C, plus here. And here which equals to NB minus Na by R1. R equals to R1. So we got here NB by X plus Na by U equals to NB minus Na by R1. Okay. So the ray that has refracted at A, this is the point A. So the ray that has refracted at A suffers another refraction at B. Okay. So when the ray is refracted at A, point A, so at point B, so it is travels like this from A to B. So at point B, again it suffers to refraction here. Right? So on the concave surface with radius of curvature R2 here. So at the B, the ray is refracted and reaches I on the principal axis. So here this is. So now this ray reaches a point I on the principal axis. So here the image Q of the object due to the convex surface. Here the Q is the image. When this Q of the image will be formed on the principal axis means if there were no convex surface, concave surface. Okay, if there were no concave surface, then the image of the Q will be formed. Okay, so here I is the image. Okay, here I is the image for the concave surface with radius of curvature R2. So at B, the ray is refracted and reaches I on the principal axis. Right? So the image Q of the object due to the convex surface is taken as object for the concave surface here. So we can say that I is the image for Q for concave surface. Now this I is the image for Q. Okay, for this concave surface. So from this we can write object distance, that is U equals to PQ here. Okay, so this is the object now. Q is the object to this image I for concave surface. So from P to Q, that is the object distance, and P to I is the image distance. So U equals to PQ, which equals to plus X, and PI equals to V, and R equals to minus R2. Okay, so for refraction, the concave surface of the lens is considered as medium 1, and surrounding medium is considered as medium 2 here. Okay, concave surface is the medium 1 and surrounding medium now that is medium 2. So hence the suffixes of refractive indices interchange. So then we get here N1 equals to NB, N2 equals to NA. Before N1 equals to NA, N2 equals to NB. Now N1 equals to NB and N2 equals to NA. So substituting the above values in the equation. So what we'll get here? So what is the equation? N2 by B minus N1 by U equals to N2 minus N1 by R. So substitute the values here. N2 equals to now NA. So NA by V minus N1 equals to now NB. So NB, U equals to X plus X. Right? So plus into minus, minus only. So NA by V minus NB by X equals to NA minus NB by minus R2, because here we have R equals to minus R2. So take this as equation 2 here. So by adding equation 1 and 2, we get here. So NA by V plus NA by U equals to NB minus NA by into 1 by R1 plus 1 by R2. Okay, from equation 1 and 2, you got this equation here. So equation 1 is here, NB by X plus NA by U equals to NB minus NA by R1. And here NA by V minus NB by X equals to NA minus NB by minus R2. So here this NB by X will get cancelled. So finally we got here NA by V plus NA by U equals to NB minus NA into 1 by R1 plus 1 by R2. So dividing this with NA, okay, dividing both sides by NA, we get here. So NA by V into NA plus NA by U into NA equals to NB minus NA by 1 by R1 plus 1 by R2 into NA here. Sorry here. Wait. So here NA by V into NA. So plus NA by U into NA. So equals to NA into, here we can write NB minus NA into 1 by R1 plus by 1 by R2. So here NA gets cancelled and NA gets cancelled. So what we'll get here? Okay. So from this we can write here 1 by V plus 1 by U equals to, so here NB by NA minus NA by NA into 1 by R1 plus 1 by R2. So here NA gets cancelled again. So what is the remaining here? 1 by V plus 1 by U equals to NB minus 1. Okay. So here NB A here. So NBA minus 1 into 1 by R1 plus 1 by R2. So this is derived for specific case for the convex lens. So we need to generalize this relation. So for this we use sign convention. Applying sign convention to this specific case we get, so 1 by V minus 1 by U equals to NBA minus 1 into 1 by R1 minus 1 by R2 when we apply sign conventions. When we are not applying sign convention, this equation is used for convex lens. So we know that 1 by V minus 1 by U equals to 1 by F. So substitute instead of this. Here we have 1 by U minus 1 by V. So instead of this, we can write here 1 by F. So we get here 1 by F equals to NBA minus 1 into 1 by R1 minus 1 by R2. So if the surrounding medium is A, then the relative refractive index could be absolute refractive index of the lens when surrounding medium is A. So 1 by F equals to N minus 1 into 1 by R1 minus 1 by R2. Right? So that is about lens maker's formula. So here we have one question. So what is the focal length of double concave lens kept in air with the spherical surfaces of radii R1 equals to 30 centimeters and R2 equals to 60 centimeters. So take refractive index of lens as n equals to 1.5. So here given double concave lens. Right? So here given double concave lens kept in air with the two spherical surfaces of radii R1 equals 30 and R2 equals 60. And given refractive index, lens is n equals to 1.5. So by using of sign convention, we get here R1 equals to minus 30 and R2 equals to 60 centimeters. Right? So also given here n equals to 1.5. So using formula 1 by F equals to n minus 1 into 1 by R1 minus 1 by R2. So substitute all the values in this equation. Right? So 1 by F equals to 1.5 minus 1 into 1 by minus 30 minus 1 by 60. So solve this equation here. So we'll get F equals to minus 40. Say exactly we'll get here 40, right? So here this minus indicates that the lens is divergent. We know this concave lens is the divergent type of lens, right? So this minus indicates that the lens is divergent here. Yes. So here the focal length of this double concave lens when it is kept in air with the two spherical surfaces, that is 40 centimeters. Right. So with this, we completed this chapter. Yes, we completed the fourth chapter also. So all of you complete your classwork. I hope all are completed up to third chapter. So complete this chapter also. Yes. So in the next class, we'll start a new chapter. Yes. Okay. Thank you, all of you. Thank you. We'll start a new chapter in the next class. So, all of you complete your classwork as soon as possible. You have to complete your classwork. Yes, very good. Yes.
Students, wait for a moment. There is a network issue. It will take 2 or 3 minutes. Just relax for 2 or 3 minutes. Okay. Students, wait for 1 more minute.
Good afternoon, Marandal. Welcome to Shanvi Learning Services. Instead of Hindi class, I'm taking now. So please stand line. Let us share slides. Please stand line, all of you. Stand line. Raghuvaran, please unmute. Nitish, please unmute boy. Nitish. Nitish Pailwan. Can you see the screen?
Yes,
Okay.
sir.
Can you see the
Okay, sir.
screen? Children?
Yes, sir. Yes, sir.
Okay, fine. Thank you. So as we have discussed in last class, like we eat solids, drink liquids and breathe gases. Okay. So as you know already, our blood is supplying that solid material, like what we are taking, that food, it's converting like as sugars, like glucose materials, and it is transporting to our body parts. And what we breathe, the air what we breathe is also transported to the cell to release energy, and water also will be supplied overall the body with that. Okay, do you think that that it is possible to transport all the three types of materials through a single system? Yes, it is possible, and let us study how these are transported in our body. Have you ever observed a doctor holding the wrist of a patient? Have you ever observed? A doctor is holding the wrist of a patient and looking at his watch for a minute. What is that he is trying to find? See, children, he is trying to find the pulse. Okay? The doctor is trying to count the heartbeat of the patient. And try counting your own heartbeat. Now, let us do one activity. Activity 1. See, observe carefully, all of you. Let us do one activity here. keep your index and middle finger on your wrist below the thumb, as shown in the figure 1. Your index finger is this. Chuvudu velu. Okay, middle finger. Both fingers you can take and keep your index and middle fingers on your wrist. This total wrist only, but you have to keep below the thumb. Below the thumb, I shown in the figure. And you feel something pushing you. Okay. You feel something pushing your fingers like rhythmically up and down, up and down. Okay. Now let us count the rhythm. Okay. That rhythm which is called the pulse. The rhythm which is called the pulse. And here we have to take for a minute or 2 minutes, 5 minutes like that. Here we have to take 1 minute. For a minute. Now stand up and jog for 1 minute at the same place. Note the pulse for a minute. Same as this by taking your index finger and middle finger. Okay. On your wrist below the thumb. Below the thumb I shown in the figure. And you have to take readings of at least 2 of your friends also in the same manner. And record your readings before the jogging and after the jogging. And your friends' readings also before the jogging and after jogging. Okay. And record in the following table. See here, table is given vertically like serial number 1, 2, 3. Name of the person. If that first Vaishnavi, then Vaishnavi may name before the jogging, after jogging. Like before jogging means at rest. After the jogging, what is that for a minute? How many counts you have? And next serial number 2, your friend name. Serial number 3, your friend name. The name of the person. And at rest, what is that pulse rate? And after jogging, what is the pulse rate? What is the count for a minute? Okay. Let us try to do that activity. So please cooperate, children, and don't feel shy and try to do this activity, all of you. Now let us take one person help. Who is ready to do that activity? Yes, here. Ayaz is ready. Okay, thank you, Ayaz. Ayaz is eagerly waiting to do that activity. Very fine. Now, please unmute, Ayaz. Please unmute. Unmute. What happened? Anybody? Sri Lakshmi, Srinidhar Reddy, Ashish, Nitish, Malyala, Bhanot Ashok. What happened? Rajendra Gadapa, Bhavyasri, Fatima. Are you ready? Please raise your hand. Let us do that activity. Very funny. You can observe something. Here he is ready, I think. Vivo 106. Okay. Madhavi, are you ready? Madhavi, please unmute. Good afternoon, Madhavi.
Good evening, sir.
Okay, good evening. Madhavi,
Sir,
please take your index finger and middle finger as shown in the figure, and please stand line. Thank you, Madhavi, for your participation. See, take your index and middle finger on your wrist. Okay, this total wrist only, but you have to take below the thumb finger, like shown in the figure, like, okay.
Okay,
And
sir.
something little bit vibrations you will get. All of you, please, you can do. Not only
Yes,
Madhavi,
sir.
you can do.
Sir.
Okay, you will feel like something pushing your fingers, like a little like a vibration type.
Yes, sir. Coming,
Okay.
sir.
Is little what? Like not pushing with hands like that, just a little vibration mode we can. Okay.
Yes, sir.
All of you, please take your like index finger, middle finger, and on your wrist below the thumb, as shown in the figure. Like you just observe that vibrations, like rhythms. Okay, some like you will feel something pushing your finger rhythmically up and down. Okay, I will tell like Madhavi, be ready. So now,
Yes, sir.
please stay in line. See, we have to do this for a minute now.
Okay.
Now watch is ready. Are you ready, Madhavi? Madhavi.
Yes, sir.
Okay, I will tell that.
Yes, sir.
When I say to start, you have to start for 1 minute. Okay, please close your eyes and be ready.
Okay, sir.
Please close your eyes and be ready, and just you concentrate on that vibrations. Now not just wait 5 seconds. After 5 seconds, I will say. When I say stop, you can stop and count that. Okay, ready? 59, 60, start. Mother, start. Okay. Close your eyes and think. Just you count how many times you got that. All of you, please do that. Akila, Devi Prasad, Sailata, Mustafa, all of you can do. You'll get experience. Here Meghana is doing, Devi Prasad is doing, Sharanya is doing, Nani is doing, Ramakrishna also doing. Madhavi, please stop. Madhavi. Please stop.
Yes, sir.
Okay, like you just write that what is the count per minute in paper. All of you, please,
Okay,
you can
sir.
write that. You can write that pulse
sir.
count for a minute in your paper. Somewhere you can write,
sir.
okay?
Yes, sir.
Madhavi, please stand up. If you don't mind, can you Madhavi,
Sir.
now have you written, have you recorded that value on that numbers? How many times?
Yes, sir. I recorded, sir.
Okay, very good. And be ready.
Yes, sir.
Please jog there, jump for half minute or 1 minute, I will say.
Okay, sir.
You can do that, no problem. Like,
Jumper, sir.
yes, there only you can jump, jog, just like. Okay,
Okay.
come on, start. Like skipping type. Very good, super. Slowly. So here she is doing something exercise. Various exercise are like jogging or walking, something you can. Okay. Okay.
Right.
Madhavi, just jump. Come on, I like that. I like that. Okay, okay, fine. Just feel like skipping. Well done, well done. Just for 10 seconds more. Okay, well done, Madhavi. Please sit. Take your position. Same as this, take index finger and middle finger, same on wrist. Okay, below the thumb. Okay, close your eyes
Yes, sir.
and start counting. Start. So here at rest, she was done, and now after jogging, she is doing that count. For a minute. Please stay online, all of you. Stop, Madhavi, stop. Madhavi,
Okay, sir.
you can stop. Okay, please write that
sir.
count. Write that count for a minute.
Okay, sir. Wrote.
Okay. Okay, fine. Thank you, Madhavi, for your active participation. Appreciating you.
Thank you, sir.
And
Thank you,
before
sir.
that jogging,
Yes, sir.
what is the pulse count for a minute?
81, sir.
Okay, super, 81.
Yes, sir.
After jogging, what is the pulse count for a minute?
104, sir.
Excellent. Claps. If you please appreciate that.
Sir, after jumping, yeah, going faster. Very
Yes,
fast.
yes, very good, very good. So what you have observed, like, okay, fine. Please, let I ask anybody.
Thank you, sir.
Reddy, please unmute yourself. Srihita Reddy. Srihita Reddy.
Yes,
Srihita,
sir.
good evening.
Good evening, sir.
Okay, as Madhavi done perfectly, like what is the count of before jogging, that pulse count, 80?
81, sir.
Madhavi, is it 81? Okay, fine. After
Yes,
count,
sir. 81.
after jogging?
104.
104. Okay, what did you observe
After-
in between the two counts? Before jogging, after jogging?
Yeah.
Which one is more?
After jogging, sir.
Okay, superb. Akbar also responding. After jogging, fine. So before jogging, it was like 80 change, and after jogging, 100. What is that number? 104.
104.
104. Before that, 80?
81.
81. Okay. Before jogging, 81. After jogging, 104. So here, by that, what you conclude, Akbar? Let I give choice for Akbar. Akbar, good evening.
Good evening, sir.
Okay, good evening, Akbar. What you conclude by these readings? By this count for a minute before jogging and after jogging?
So different, sir.
Okay, different is there, right? Before jogging, it will be less. Less
Increase.
count for a minute, and after jogging, it will be
Increase.
increased. So
First
here,
rate,
okay, fine. And thank you, Akbar. Next. Fine. So really great, who have involved, who are participated actively, like Madhavi and next
Thank you, sir.
Srihita Reddy and Akbar and all who have done that. So special thanks for Madhavi. See here,
Thank
as Madhavi done perfectly, practically before jogging it was 81 and after jogging it was 104, right? 104. So there will be difference before the jogging and after jogging. So what is the reason behind of that? Can you tell anybody? Please raise your hand. Why it was increased after the jogging? Nothing to worry. Just what you are thinking, you just can share whether it is correct or right or wrong. Not a problem. Okay. So participation is important. Devi Prasad. Where is Devi Prasad? Just wait, I will come to you. Please turn on your camera. If you turn on your camera such that I can give choice to you. Like, okay. Abhilash, are you ready? Abhilash, please unmute yourself. Abhilash. Who are ready? Nitish, are you ready? Ganesh, Nitish, Raghuvaran. Okay, Raghuvaran, please unmute. Raghuvaran.
Yes, sir. Yes,
Good
sir.
evening, Raghuvaran.
Good evening, sir.
So here, mother and sister have done that jogging. Before jogging, I have observed 81, and after jogging, it was about 104. Okay, what is the reason behind of that?
Sir,
What is the
heartbeat, sir. Heart pumped very fast on the blood circulation.
Very good. Okay, why need to pump more?
Because she is the doctors are working some hard work.
Okay, so vigorous exercise, right?
Yes, vigorous.
After doing that vigorous exercise, why need to send that blood very fastly?
Muscles done the work, sir. So vigorous muscle need a blood.
Okay, good. And we have done vigorous work means we required more
Oxygen and blood.
yes, energy, right?
Yes, sir.
If you require more energy, how can energy will be released? We have discussed in the lesson.
Yes, sir. Lactic acid.
Carried out near to the cell, then only it will go for the respiration process. After that, energy will be released, right?
Yes, sir.
Okay, super. And please can conclude that.
Okay, sir.
Raghuvaran.
Sir.
Very good, Raghuvaran. Thank you.
Thank you, sir.
See here. Madhavi sister,
Sir,
pulse rate before jogging 81, after
Yes, sir.
jogging 104.
yes, sir.
After jogging, that Madhavi needed, like Madhavi required more energy to do that vigorous exercise.
Yes, sir.
Then she required more energy means how energy will be released in our body? By cellular respiration.
Yes.
For cellular respiration, what do you need?
Oxygen needs, sir.
Oxygen. Then who will supply the oxygen for the cell? Blood.
Blood.
Blood,
Then
sir.
who will pump the blood?
Heart, sir. So heartbeat is more.
There is a need to pump more blood. By that pumping more blood, we can transport oxygen also more.
Yes, sir.
By the sufficient oxygen, by utilizing the sufficient oxygen by the cell, it can be produce more energy.
Yes, sir.
Energy can be produced more. By that energy, she can do that vigorous exercise because she required more energy. So that's why here there is a change in between that pulse rate, like counter change in that before jogging and after jogging. Okay.
Thank you, sir.
Okay. Now here serial number 1. Name of the person is Madhavi. At rest 81. And after jogging, it is 104. Fine. Like that, you can take your friend's help also and make them to count that particular pulse rate before jogging and fill in the blanks, the table, and after jogging, you can also check. Okay. So that is a activity, very interesting activity. And see children, let us do one more activity also. But next class, because if I say today, if I inform you, you can be ready with the resources. Here we need 2 things, that's it. Simply, like no need to go for anywhere and no need to search, no need to go for anywhere to take that, okay? Simply we need 2 things. One is shed to button. However, your old like sheds will be that for that button you have to collect one shed button, and along with that one toothpick you can take. Toothpick you can take. Okay. Let us check our pulse. Let us check our pulse by making our own apparatus, instrument. Okay. required things, the required materials are, one is shutter button and one is toothpick. Okay, the stick and button you can be ready. Let us do that activity in next class. Not only one person, we have to do, all persons can do that at a time. Okay, here I am ready with these resources. I brought you to I brought here this button and toothpick to show you, and such that you can come up with a button and a toothpick in next class. This is not a spoiled one. This is not any wasted material. Today itself you can collect this shutter button and a toothpick. Keep with you. Okay. Yeah, no need to announce that when do you have class, sir. No need to like announce the timetable also. If I have tomorrow or day after tomorrow, whatever it may be, you just keep with you this button and a toothpick. Be ready. When I asked, you have to be ready with a button and a toothpick to show. Let us make our own pulse indicator. Pulse indicator to count the pulse for a minute. Are you ready? Okay. So if you participate actively, such that I can give chance to involve in that activities. Otherwise, I can teach and go. So as you are participating very actively, that's why. So that is a good nature, and you have to come with a button, shutter button, and just a toothpick. Let us do that, because some of the people who have interest to do that may also get a choice. Okay. As we have less time, may not able to give choice for all. Don't feel who did not get the choice. Okay, you will get chance for future also. So that's why I'm informing you before itself. You have to be with a shutter button and a toothpick, such that in next class, let us do like I brought already. I'm ready. Okay, I'm ready. Okay, just I'm showing how to do and how to make that pulse indicator. I will show you in next class. Okay. And if you be ready, you can also check the pulse count perfectly for a minute. All persons can do this. Okay. Okay. And now let us read once. What is that activity? See, children, as this is important, like, do you think like, we eat solids, drink liquids, and breathe gases? Do you think that it is possible to transport all the three types of materials through a single system? Yes, exactly. And here let us go on this activity. We see that pulse rate varies from person to person. Like as Madhavi's pulse rate before jogging 81 and after jogging 104. So if you do that, you will also get same 81 and after 104 like that. Don't think. Okay. Pulse rate varies from person to person and situation to situation. Okay, children. Don't think the pulse rate same for all. The pulse rate varies from person to person and situation to situation. When you are afraid or excited, the pulse rate goes up. When you are afraid or when you are excited, when you do the vigorous exercise, then pulse rate goes up. Observe your pulse rate while climbing stairs. Okay, you try to climb the stairs. While climbing stairs, you can observe your heartbeat will increase. Try to go for 3rd floor, 4th floor. By climbing stairs, you can observe your heartbeat. And while running also, you can check the pulse rate, the rhythmical up and down feeling, like you'll feel something pushing your fingers, like when you check here. Okay. So here there is a relationship between the pulse rate and heartbeat of our heart, because here it is pumping that blood in the arteries. In that arteries, like you will feel rhythmical vibration up and down. You feel something pushing your fingers when you do this activity. that rhythmical vibration is a pulse. It is happening because of pumping of blood. If heart stop the pumping of blood into the arteries, then there will be no pulse. So there is a relationship in between heartbeat and pulse. Heartbeat and pulse. Okay, now let us try to find out more about this relationship. For this, you have to make your own pulse indicator. For that pulse indicator, see children, take an injection bottle lid or shed button. Better to take shed button. Take an injection bottle lid. Okay, injection bottle lid will be no. Like for glass bottle will house one round button type plastic cap. That cap you can take like this one will be that. Otherwise you can take a button, your wish. Okay. And take one matchstick. Okay, matchstick. Okay, and how to make it and how to follow the procedure to check that pulse. You can discuss in next class. You can discuss in next class. Okay. So this is a concept, children, and thank you for your active participation. As time up, I'm going to wind up the session. Don't forget to bring, or if possible, today itself we can collect a shed button or injection bottle lid and a toothpick. Okay. So such that by guidance of me, you have to make the pulse indicator, and you can, as here Srihita Reddy is ready with that. Thank you. So please, you can be ready, and whenever class will start, then I can explain about how to make that pulse indicator, and after that let us check that pulse by using this pulse indicator which are made by yourself. It is, we are making ourselves, right? So be ready for that activity, children. Okay, don't forget to bring or keep with you like injection bottle lid or shed button and toothpick. That's it. Okay. Thank you once again for all who are participated actively, and I hope I'm expecting my children can also participate very actively in next class also. Okay, and you will be appreciated also. And thank you one and all. Let's meet in next class. Okay, thank you.
You are my hero forever. You are my hero now.